the eye in the top right-hand corner of your screen for even more Disney Junior, where the magic begins.
On a number line. So physicists will often impose number lines or grids onto physical reality to help them keep track of positions and locations. Now, I don't know why my number line did this with the blocks, but there's supposed to be numbers underneath all these tick marks. So go ahead and take a moment to write these numbers down with me, because we will need them for the problem. I'm doing my best to stay neat. -1, so this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So think of this number line as kind of like replacing your x-axis. And we're just looking at motion in the horizontal direction. And then the second number line, I think, is exactly the same. Yes, it is. -10, -9, -8, -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. Do you ever notice that you write your numbers differently, like your numbers 2 differently? Like I wrote it curly here, but then I wrote it like pointy there. And it's only sometimes, like I switch it up, and I don't know why. Like it's second nature. I do my 4s the same every time. I think it's 4s and 2s that I have the ability to write differently, but I only do that with my 2s. I don't know. Maybe it's just me. Anyway, let's look at this first example. We're going to consider the motion of the following tumble buggy. What is the buggy's displacement, and what is its distance traveled? So I'll do distance traveled in blue and displacement in purple. So my displacement is going to be my change in position. So I started at position -8. And at 3 seconds, the buggy ended at position 7. So I could count all the tick marks between -8 and 7, or I could do a little bit of math. I'm going to do that over here. So my displacement is my change in position, right? Change in position can be abbreviated. Oh, why did I say change in mass? Got chemistry on the mind, maybe, I don't know. Anyway, change in position can be written in a mathematical way like this, delta x. X is typically what a physicist will use to describe position, and then a mathematician will use the variable delta, or letter delta, I guess it's a Greek letter, to abbreviate change. When I'm doing my change in something, the way that I can calculate it pretty easily is by taking the final position, or the final value, minus the initial. This is how you guys actually find slope. Like I'll provide that little connection up here. Remember how slope is delta y over delta x? And you always do y2 minus y1 over x2 minus x1, right? Y2 is like your final y value, and y1 is your initial. Same thing here with my change in position. To find my change in position, I'm going to do my final position minus my initial position. So my final position was position 7, positive 7. I'm going to minus my initial position, which was -8. And minus a negative right here, what I have in the middle, becomes a plus. So minusing -8 is the same thing as adding 8. So my displacement is 15. Boom shakalaka. Now you could have counted the tick marks all the way over, but that's not always going to be an option that's available to you. There's going to be many times where we're not working with nice values that line up perfectly on a tick mark. So you must know how to calculate change in position quickly by doing final minus initial. That being said, let's look at distance traveled. So my distance traveled is the length of my path. So the length of my path is going to be non-directional, right? I'm not going to need a value. Oh my gosh, I think I forgot direction on my displacement. I did. What direction did this tumble buggy get displaced in? There's a lot of ways to say that. I could say that it went 15 tick marks to the right, or I could just use positive and negatives. On this number line, the positive direction is on the right side. My numbers get more positive. The negative direction is on the left side. So I could have just said that my displacement was positive 15. I totally forgot to explain that. My apologies. So let me box that. That being said, now that I reminded myself, let's talk about distance, because distance is non-directional, so I don't need to worry about if it's positive or negative. I'm just worried about what's the length of this path. Now, if you counted the tick marks, you already know. If you did this delta x calculation, you already know. The length of this path is 15 tick marks long. So this tumble buggy went 15 units. The reason I'm calling it units is because I don't know if these are centimeters, meters, inches, miles. I don't know what the length of these tick marks are, so I'm just going to call them units. But that's my my distance. I don't need to say if it was to the right or to the left. Let's do one last example. Consider the motion of the following tumble buggy. What is its displacement and distance traveled? So I can see now that my tumble buggy is going the opposite direction. This is going to affect my displacement. So my starting position is now over here at 7, and my ending position is on the left at -8. So when I find my change in position, which is my displacement, as a reminder, displacement is just your change in position. I'm going to take my final position and subtract my initial position. Now in this case, my final position is -8. And my initial position is +7. So I'm going to take -8 and subtract 7. When I do this, I end up getting -15. Now you can see why a physicist might conveniently refer to directions as positive or negative, because my answer has already incorporated direction in for me. My displacement was -15 units, meaning it went 15 units in the negative direction. I could rewrite this as 15 to the left if I wanted to, and say that negative means the leftward direction on this number line. But, oops, I didn't go far enough. But it's entirely up to you. More often than not, you'll probably find yourself using positive and negative signs out of convenience, because you won't have to take the additional step to describe left or right or north, east or south. You'll just be able to do positive and negative, and the math will incorporate that positive or negative sign into your answer. So now that we've got displacement, let's look at distance traveled. Remember, distance traveled is the length of this path, and it's non-directional. So this tumble buggy traveled 15 units. Was it in the negative direction? Absolutely, but we don't care that it was in the negative direction. So my distance traveled is just 15 units. Not -15 units, just 15. If you put -15 units, that would be wrong, because you can't travel a negative distance. It'd be like saying, hey, I went -5 miles to school today. Your parents would probably be really confused. How'd you go -5 miles? There's no such thing as a negative distance. Why? Because it's non-directional. That being said, let's look at these follow-up questions. So was the distance traveled by the buggy the same as the displacement of the buggy? Well, if I review this, in one example it was, but in the second example it wasn't. So I guess the best answer to this is sometimes. I wish I could do that shrugging emoji. Can I do that shrugging emoji? Can I add emojis? Ooh, where's the shrugging emoji? The one where she's like, sometimes. But yeah, so sometimes distance and displacement are the same thing. Which quantity better describes the buggy's motion, distance or displacement? I guess the key word here is motion, and not travel. If it was travel, I guess I'd say distance, but for motion, I guess I want to know what the direction of motion is. So displacement would be better in my opinion. But if this was like referring to the buggy's travel, I could see how maybe distance might be better. For example, with the wolf. According to displacement, the wolf didn't travel anything. They went 0 meters. But in all actuality, they did travel a distance of 12 meters. So shouldn't we take that into consideration? So I guess they're both important in different ways. So maybe I should explain that. Distance is important when position doesn't change. Or maybe not when position doesn't change. Maybe it's important, yeah, I guess important to describe the length of travel. because maybe they just backtracked a little bit, maybe their position changed a little bit, but they traveled much farther. That's kind of where my mind's going. But then displacement is really good if I want to know direction. Like if the direction of this object's motion was really important to me, then I'd use displacement. So you can see where some situations we might want to use displacement, and others we might need to use distance to describe an object's motion. And that's where we're going to have to differentiate which is going to be more valuable to us. So that last question, when are distance traveled and displacement not the same? So let's look up here at this example where they were not the same. They were not the same because displacement was in the negative direction and distance was non-directional. But they were the same number. So what's a better example? This one I think is a better example. We had totally different numbers, 12 meters versus 0 meters. I think that the reason why distance was so much different than displacement is because the wolf backtracked. Meaning they went backwards in direction at different points in their travel. Like the wolf went right and then he went left. He went down and then he went up. So that backtrack caused the displacement to be significantly different from the distance. And even here, you could kind of say that like when the buggy was going backwards, excuse me, you could say that the buggy's displacement was different than the distance because it was going in the backwards direction. So I would say that they're different when an object moves backwards or it goes in the backwards direction. And I'll even put backwards like in like quotations, because backwards could mean they backtracked, or it could just mean that they're going in the negative direction. But yeah, backwards, yeah, I think is kind of ambiguous, but I think we know what we mean when we're saying backwards. That being said, let's start doing some tries here. So we've got a runner now who is on this timeline, and they're backtracking. They started here at 0 seconds. I'm going to mark that. Started here at 0 seconds. They were at 1 second here, 2 seconds here, 3 seconds here, and whoa, 4 seconds, they were back here again, and 5 seconds, they were back here again. So obviously the runner must have turned around during their length of travel. What I'd like you to do is pause the video, try to find displacement and distance traveled for this runner. All right, if you've unpaused, I'm going to assume that you have attempted this and you're ready to check your answer. So my displacement is my change in position, which is my final position minus my initial position. Notice I'm writing it down every time. I'm going to do this to cement it in my brain. If you're someone who doesn't like math, you should definitely be reciting this over and over again by writing it down, reading it out loud, because it probably won't be something that you memorize without some additional effort. That being said, my initial position is at, oh, I forgot to number this, -10. I'm just going to skip -8, -6, -4, -2, 0, 2, 4, 6, 8, 10. Okay, so they started, this must be 7. So they started at 7 and they ended at 4. So I'm going to take 4 minus 7, and my displacement ends up being -3. I'm just going to do -3 instead of saying 3 to the left because I am lazy and, you know, trying to save my effort. So that's my displacement. I went -3 meters. My distance traveled is going to be different because I went here and then looped back around and went here. So my first length of travel is from 7 to -2. So 7 to -2, that's 7 units right here, from here to here. Maybe I should mark that better. From here to here is 7, and then from here to -2 is just 2, and then on the way back from here to here is 2 again, and then from 0 to 4 is 4. So my distance is going to be the sum of all of these lengths. So 7 plus 2 plus 2 plus 4 gets me 8 plus 7, 15 units. Skadoosh. So hopefully that one made a little bit of sense, and if not, the explanation hopefully clarified for you so that you're ready to move on to the next one and try it. So once again, it's the same number line, so I'm going to number this every 2 tick marks, -10, -8, -6, -4, -2, this will be 0, this will be 2, this will be 4, 6, 8, 10. Nice, 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 nice. All right, go ahead and go for it. Pause the video and unpause when you're ready to check your answers. All right, I'm going to assume if you're listening, you are ready to check your answers. So, is this a Triceratops? I think it's a Triceratops. I forgot the name. But our Triceratops, it looks like he starts at -7. And at 1 second he's here, 2 seconds he's there, and then at 4 seconds. Wow. Whoever made this can't count, right? Embarrassing. This should be 3 seconds. It wasn't me. Okay, maybe it was. Don't judge. Anyway, it looks like this Triceratops ends at 0. Dun dun dun. So my change in position is my final minus my initial. I know it's tedious, but I'm writing that equation down until it becomes memorized on my brain like my birthday. Anyway, my initial position is -7. Wow, I can't write. My final position is 0. So I'm going to do 0 minus -7. 0 minus -7 is the same thing as 0 plus 7. A negative becomes a positive. So 0 plus 7 is +7. Nice. So my displacement is in the positive direction, 7 units. I'm with it. Now my distance. So my distance, I'm going to draw the path. Goes here to there. Nice. So I'm going to chunk this into segments. So I know from here to 0, -7 to 0, that's a length of 7 units. And then from 0 to, this is 7, that's another 7 units. And then from 7 back to 0, that's another 7 units. So my distance is going to be 7 plus 7 plus 7, or in other words, 7 times 3, which is 21. Boom, shaka, laka. So we can see that every time that this object or these objects backtracked, our displacement ended up being significantly different from our distance. So let's move on then to these follow-up questions that may or may not be very similar to before. Was the distance traveled by the runner the same as the displacement? Nope. Not once. Let's go back. Nope, neither time. Was not the same. Which quantity better described the runner's motion? Distance or displacement? Explain why. I'm not going to think as hard about this one because I think we talked pretty heavily about it earlier, but it depends on what you're looking for. Like if I want to know what direction they went, then displacement was more valuable. If I want to know, about literally how far they traveled, then distance is more important. So distance isn't more important when I want to describe their travel length. And then displacement was more important when I wanted to describe their direction of motion. So when are distance traveled and displacement not the same? When we backtrack. When we change directions, when we move backwards, whenever direction gets manipulated, that's when distance and displacement are totally different.